Hello, everyone, and welcome back. Our next speaker is Iosif Itkin, co-CEO and co-founder of ExactPro, which is a global leader in software testing for the financial industry. I looked a little bit into it. So you have a lot of experience in AI and performance testing, and you kind of help drive like the technology transformations across major financial centers globally, which is super interesting. And I can't wait to hear more about that today, because you're going to talk about the topic, how AI can be used to develop digital twins and serve as powerful test oracles for large-scale intelligence testing. So please welcome Iosif. The stage is all yours, and we're very excited for your presentation.
Hello, thanks a lot for the introduction. It's truly a pleasure to be here. Thanks a lot for the opportunity to present at A4Q Testing Summit. ExactPro is a software testing business. We provide software testing to financial market infrastructures globally in more than 20 countries. We work with the top exchange platforms that are foundation for the global economy. In ExactPro, we do a lot of testing related to mission critical software that has very low latency, very high availability requirements, and also software that process huge volumes of data on a daily basis. We do testing for trading systems. These are complex, sophisticated technology infrastructures. But a good question is, where is the artificial intelligence there? Is there anything that is non-deterministic, adaptable, autonomous, learning, evolving, or intelligent? One can say that you just send messages into the system, and then system processes these messages and distributes them across other systems. In reality, there is one important component of intelligence that is present in most of the modern trading systems, and this component is the market itself. Trading systems connect to the real world there. Consists of market participants, both humans and robots, that represent artificial intelligence or natural intelligence of the market. When somebody is working with the trading system, it is not intelligent because it is called smart or the router. It has to be to a degree intelligent because it interacts with external intelligence represented by many participants that have competing interests. So all other traders, brokers, they do not necessarily have the same interests as you do. So when you write software to trade in the market, you have to take into account that this software is connected to external intelligence. Now, when people do explore a variety of systems that rely on AI technology stack, such as LLMs, they frequently ask questions how to deal with it, because you have to interact with something that is unpredictable, that is non-deterministic, and that you often can control. And it is exactly the case for the algo trading software. You interact with markets that are not predictable, that you can't control, and that represent external intelligence. It means that the same testing methods and approaches developed to test algo trading systems, they are also applicable to test AI-enabled software. In 2025, everyone should be already aware that the systems based on AI technologies, including large language models, are not necessarily reliable, and there are many high-profile reports about problems that are present in AI-enabled software. There are databases that lists every single embarrassing event that happened, and of course everyone is looking to do something to avoid having such things in their own systems, the systems that are important to them, the systems that are important for their business. One of the ways to decrease the probability of the outage is to do a thorough software testing. And to do software testing, one has to understand some fundamental concepts. The software has changed, there are new technologies, but some fundamentals related to software testing remain the same. In particular, I would like to cover today the topic of test oracle that is fundamental to software testing, and I do believe that it should be more widely used in our practice. How to check that some concept is important and is a growing trend? One can go to Google and check if there is a growing interest. For example, if we are looking at AI, clearly the topic is trending. So I've decided to check test oracle concept. So is it trending or not? And was my first screenshot. And after drilling down into this information, it looks like I am the only one who is interested in test oracle, or maybe there is someone else not far from Tbilisi. In reality, if we do expand the search over the last 15 years, one can say the topic slowly loses in its search results. So I decided to recheck it and went to see if it is somehow related to the overall decline in software testing. Well, not necessarily. So people are still searching for info about software testing. So there was a recent spike, and now interest slowly decreases. But there are still many countries that are very keen on learning more about software testing. I would like to point out that Sri Lanka is at the second spot in Google Trends in relation to software testing. Very nice to know. Okay, so even if one goes to YouTube and checks, are there any videos available on the topic of test oracle? There's only a handful of YouTube videos on the subject. So I would highly recommend all 4 videos present here, but they all refer to the same set of presentations from the same author, Doug Hoffman. So it would be fair to say that the topic is not sufficiently covered in YouTube at the moment. Even in ISTQB syllabus for certified tester foundation level, term test oracle was removed from version 4.0. So it's not considered to be sufficiently important. I personally believe that any educated software tester should be very aware of what test oracles are, and I will walk through several definitions of the term and also give some historical context. The term test oracle was introduced almost at the same time, a bit earlier than company Oracle was created in 1978. Test oracle refers to Greek mythology or history, and oracle is someone who can predict the future or tell the truth. Delphi oracle was present in the temple of Apollo. Apollo is the god of truth, and the idea is that there is something out there that can tell you the truth you can rely on. The Greek mythology refers to King Croesus, who was extremely rich and who was very fond of Delphi oracle. So when he decided to start or participate in the war against Kairos the Great, he decided to ask Oracle on whether he should send army against Persians and whether he should take allies. The judgment from the oracle to Croesus proclaimed, if he sent an army against the Persians, he would destroy a great kingdom, and that he should discover the most powerful of the Greeks and make them his friends. So when he received this response from the oracle, he was very happy because his assumption was that he will start a war with Cyrus the Great and will destroy the Persian kingdom. In reality, it appeared that in the process, he destroyed his own great kingdom. So the test oracle provided response that was correct, but probably it required additional follow-up questions. Also, one can argue that part of the proclamation can be misinterpreted, and the other part of proclamation is more or less irrelevant. This is what happens to test oracles in our practice, in our work, and it is something to be aware of. ITQB glossary defines test oracle as a source to determine an expected result to compare with the actual result of the system under test. There are some problems with this definition. In particular, it implies how the testing is done and that expected result can be known in advance. ITQB glossary also defines the term pseudo-oracle, an independently derived variant of the test item used to generate results which are compared with the results of the original test item based on the same test inputs. Pseudo oracles are also known as digital twins. So it is independently written software that can be used to explore the output of other software. Wikipedia also refers to test oracle as the provider of information that describes correct output based on the input of a test case. But in the world of AI systems, complex AI systems such as language translation, computer vision, everything, it is often not easy to say what is correct and what is not correct. So this definition is not ideal, even though it refers to a wide body of research literature. So it's not easy to find enough information about test oracles in I would say in practical materials, but if one goes into ACM or IEEE digital libraries, there are tons of papers related to test oracles. But even here, it defines test oracle as a procedure that distinguishes between the correct and incorrect behaviors of the system under the test. And it is based on assumption that one can say what is correct and what is incorrect. It implies that there is such thing exists like a true oracle. A true oracle is something that can provide correct results for every possible input independent of the system under the test, and it ensures faithful and thorough testing and suitable for any test case. So everything is good about complete oracle apart from the fact that it does not exist. What exists is the different types of oracles, but before we switch into it, I would like to quickly cover the topic of naming. When you start looking into working with AI systems, it is likely that you will see phrases like evaluation of LLMs or evaluation of AI software or red teaming of LLMs, red teaming of AI software instead of software testing. So there are reasons that these terms are used instead of software testing. So to a degree, all three things, red teaming, evaluation, and software testing, is doing some exploration of the software in order to obtain information. So what is the difference between these three terms? The main difference is in intent. So red teaming is intention to find a single bug. So not to explore software in order to provide more information, but to find that one or a few defects that are critical to breaking into the system. So the difference between red teaming and software testing is in intent. The same is true for evaluation. I also call it wipe testing. So wipe testing is when you do not have intention to find defects. Instead, you have intention to evaluate software. So there is wipe coding, there is wipe testing. Evaluation is wipe testing. Software testing, on the other hand, my favorite topic, is empirical technical investigation with intent to find defects. So intent matters. Intention behind software testing is finding defects. Software testing is about finding bugs. Software testing is intelligent activity that consists of selecting actions to perform, so what to do, mechanical part related to performing these very actions, and judging part of understanding the consequences of your actions. And these three different activities have different cognitive workload. It is very easy to incorporate into CI/CD some mechanical steps, some mechanical checks. It is more difficult to figure out what would be the good test scenarios, what would be the good test actions. So intelligence is required to design test actions. Judging when something goes wrong is a very difficult cognitive activity because you have to assign value to your observations. There are many non-inclusive possibilities for every experiment. It is possible that the observations match the model assumptions of the system under the test. It is possible that something is wrong with actions, with assumptions, or something is wrong with the system under the test, that it contains defects. And software testing is activity intended to find defects. A good definition of the test oracle is that a test oracle serves as a mechanism to recognize issues during software testing when they arise. Testing can only show the defects are present in the test object. Testing cannot prove that there are no defects. So it is not okay to think about it in terms of correctness. It is better to think about a test oracle as something helpful in detecting an incorrect behavior. Something like raising the alarm that something needs to be investigated. Test oracle is something that helps us identify when something is remarkable in our observations, or it can be used to identify that there is probability there is nothing remarkable in the observed data and there is no need to immediate human involvement. This is the definition that we use internally, and this is also definition that we believe represents better practice in most of important software testing contexts. There is no such thing as complete oracle, but there are things like partial oracles. All models are wrong, some of them are useful, and partial oracles have many different types. They are working horse of software testing. For complex systems, one can use stochastic, heuristic, consistency, diagnostic, or independent implementation or digital twins partial test oracles. In our own work, we are trying to use all types of oracles, including stochastic oracles, to evaluate data distribution. We are also building digital twins to be served as independent implementation, and we do a lot of property-based checking and reconciliation checking for consistency purposes as a consistency oracle. One way that we specifically use to generate test oracles that we can use for complex systems is to produce the source code, in this particular case in Python, based on observations from a complex system under the test. So in exchange domain, there are communication messages from traders and robots to the stock exchange. In chatbots, well, there is also traffic that is represented in messages that go from users to the chatbot, and from there to the systems of reference underneath it. The idea is to capture this traffic and use it in order to train a deterministic digital twin based on the data. Such digital twin can be used for several reasons. For pragmatic reasons, for example, to serve as an interpretable model, and also it can be more cost efficient than other things. So we often use machine learning techniques such as decision trees to produce digital twin based on observations from the data. There are lots of packages available out there. Even using standard Python libraries, it is very easy to produce such digital twins. What's important, it should not be more complex than the system under the test. Otherwise, you will spend more time debugging the digital twin in comparison to the system itself. Originally, we called this method stitch2color and used the logo on the left, but then we decided that we are excited of this approach and replaced it with the other logo that we called copy something. So take the traffic and produce a digital twin based on it. We describe it in our own practice and also in our STQB accredited certified tester training course that we periodically start in a guided tours. I do recommend everyone to explore this opportunity. And we are also preparing a book to describe both challenges of testing AI-based systems and also approach that we use to do to produce digital twins, to do property-based checking for such systems. And we do hope that this information will soon be available, and the book will also be available very soon. Thank you. Thank you very much.
Iosif, thank you so much for your presentation. It was super, super interesting. So now we have a couple questions because we still have time, so we can go through them. And I'll ask Paul to just put in the first, please. Thank you. So why do you think the test oracle concept is not present in the ISTQB CTFL syllabus? That's something that we wondered.
Yes. So to a degree, I was thinking about it as well, and difficult to say. So it is present in AI tester syllabus, and it is explored there, but it never appeared in foundation level.
Okay.
I think it is important, and it should be explored by testers at every level. One reason that I have in mind is that probably it is because some people think that on foundation level testing is easier, so there is no need to introduce complex concepts like test oracle. And also people think that it is self-evident that you can define expected results for the systems. So when dealing with conventional software, the common assumption that it is easy to understand its expected behavior. When dealing with AI software, one can argue, oh no, it is not easy to understand what is the expected behavior. That's why in AI syllabus, test oracle is covered. In foundation level, it's not covered. My personal opinion, it of course should be thoroughly explored as a part of foundation level syllabus.
Okay, so you just mentioned AI. I think we should stay with that because we have a question about AI as well. What is your opinion on LLM being a system to evaluate AI systems in general? So can that be like a concept where LLM is like able to judge AI systems?
Well, well, so the idea here is that LLM will be able to judge what is wrong or what is right, what is correct, and what is incorrect.
Okay.
So the well, LLMs are really not reliable at the moment. They do not have agency or responsibility. They are stochastic models. They give some response based on probability. So it is not possible to use LLMs to get the exact answer. On the other hand, at current presentation, there is no such thing as complete oracle. So all oracles are partial, and it is still possible to use something probability based as a stochastic oracle to explore the software. It's just very important to be aware of the limitations of the LLMs. Most of the time, we do not have any evidence that they are sufficiently reliable. We do understand that they are based on probability, and it is possible to use something based on probability to do evaluation. Evaluation itself is different from software testing because software testing is more precise activity. In software testing, you are trying to identify defects. In evaluation, you often do not do it. So in evaluation, you're just trying to confirm your bias that AI
Okay.
software that you've produced is okay. And LLM is very helpful in this because it it behaves in a way that supports your misconception. So if you are wrong, then very soon LLM will start agreeing with you. So
Okay, so it's just going to support my opinion at the end of the day.
yes, yes,
Okay.
regardless of whether it is correct or not correct. Exactly.
Okay. Well, Iosif, thank you so much for your presentation. It was super interesting and especially clarifying the questions. For everyone watching right now, please don't forget to vote for Iosif's presentation on the website. And yeah, we're looking forward to the next presentations. Iosif, thank you for being here today, and hopefully see you next year at the A4Q Testing Summit. We definitely can't wait. And yeah, to everyone else, we'll see you in the next presentation.
Thank you. Have a nice day.
Thank you. You too.
Are you ready to take your ISTQB certification to the next level? Meet ISTQB Prep, your smart AI-powered study companion. Designed for future ISTQB certified testers, ISTQB Prep gives you everything you need to prepare effectively, from realistic exam simulations to AI-driven insights. Practice like it's the real exam. Get timed ISTQB-aligned tests featuring official sample questions so you know exactly what to expect. No more second-guessing. Receive instant feedback with clear explanations, helping you understand why an answer is right or wrong. Stay on track with detailed performance analytics. Pinpoint your strengths, identify areas to improve, and watch your confidence grow. A simple, user-friendly interface makes exam prep effortless. Study whenever and wherever it suits you, right from your desktop. Get access today through GASQ or ISQI, whether as a standalone prep tool or bundled with your ISTQB exam. Study smarter, boost your confidence, pass your exam. Start preparing with ISTQB Prep today.